If you think using a consumer VPN will protect you from spies, hackers, prevent man-in-the-middle attacks, and otherwise increase your data security and/or your privacy, well, it won't. In fact, using a VPN can create a lot of problems. Keep watching and I'll explain. Now, to be clear, I'm not talking about enterprise or corporate VPNs. Those VPNs provided by your employer so you can work remotely and/or from home. Indeed, those VPNs have proven to be useful and are highly secure and don't create any user interface headaches. What this video is going to focus on are the consumer VPNs. Those VPNs sold by firms such as NordVPN, Surfshark, ExpressVPN, and dozens of others. These VPNs generally provide an unnecessary detour to the internet. They don't add anything in terms of data security and often work against you in terms of privacy. In addition, they create all kinds of interface headaches, that is, authentication issues, and I'll go over some of those in a bit more detail. I will discuss also the few good purposes for these consumer VPNs. They do play a role in certain selected situations. I'll go over some of the things you can do to mitigate the problems caused by using these products. Let's get started. VPNs evolved into existence during the 1990s when the internet itself was unprotected, that is, unencrypted at the time. In addition to government and military use, VPNs quickly became a way for businesses and other agencies to allow secure and remote access to their networks. And this diagram is an example of a traditional use of a VPN. Remote user is running VPN client software, which provides an encrypted tunnel to the corporate network. Now, VPNs don't work in isolation. They often work in tandem with Active Directory, two-factor authentication methods of various kinds in order to ensure secure access. Note here that this diagram shows an example of some traffic going straight to the internet, where other traffic may go through the tunnel. This is an example of a split tunnel VPN. About half of corporate networks are now split tunnel, whereas the other half are what we call full tunnel VPNs, where all of your traffic goes from your PC to the corporation's network before it goes anywhere else. A commercial VPN, on the other hand, serves a very different purpose. Basically, this type of VPN is designed to make it look like you're connected to the internet from a different location. When you run a consumer or commercial VPN software, your traffic gets encrypted with an extra layer of encryption to the VPN provider. At that point, the VPN provider will strip off the extra protection and ensure that the traffic is routed to come back to it rather than to you, and then forward the traffic on to the desired destination. When a service on the other side decides to return some traffic back to you, it will send it back to the commercial VPN provider, which will then alter the return address to make sure it comes back to you, adds it an additional layer of encryption, and then sends the data back to you. And that's about it. That's really all a consumer or commercial VPN does. Other than the fact that your original IP address is unknown to the web services that you're using, there really is no additional security or privacy added. And this extra layer of encryption that's provided is strictly just between you and the VPN provider. There is no additional protection offered when the transaction goes on at the rest of its journey over the greater internet. Most consumer VPNs are full tunnel, in which all the traffic gets routed this way. However, there are some that allow you to configure certain applications to bypass the VPN if needed. There's also something called an application level VPN. In this case, the application manages the VPN connection, and it is only implemented within the scope of that one application. A good example of this is the free VPN service offered within the Firefox browser. Let's take a look at the Firefox browser VPN and how it works. It's a very simple implementation of an application-specific VPN, and will only take a few seconds to demonstrate. I'm within the Firefox application, and they now have an option within Firefox, if you're configured accordingly, to provide you with instant VPN access. It's a free service. They give you up to 50 gigabytes per month of usage, which is really a lot of data if you're just browsing or doing light use on your computer. Note here I'm into what's called the Ookla or speedtest.net website. I'm currently located in northern Alabama. Now, I've altered this IP address. This is not my true IP address. I want to keep that concealed, which I'll explain a bit later. But otherwise, this is the standard Ookla test that I get whenever I run a speed test from my resident. If I click on Change Server, it's going to list a number of speed test available servers, all within the northern Alabama, southern Tennessee area. Now, if I come up here to my VPN button, click that, notice it says VPN is off. All I have to do is click this button, and now the VPN is on. It's that fast. This is what's known as a proxy-based VPN. Now, if I refresh my screen, you'll see where my IP address is completely changed. I'm now identified as under the Fastly service with this 63.245 IP address. And if I click on Change Server, it's going to show me nearby servers. Notice all the nearby servers are in Los Angeles, California. So essentially, I have traveled to Los Angeles as far as the internet is concerned. If only real travel could be that fast and easy. Now, I'm not going to bother to run a speed test at this time, but I will come up here and turn off the VPN. And I'll refresh my screen again. And now it's back to my northern Alabama location. I've blurred out my IP address here so you can't see it. But if you notice here, if I click Change Server, I'm back to the original server list for those in northern Alabama. So that is how quickly one can jump on and off a VPN nowadays, depending on how the VPN is configured. In this section of the video, we're going to talk about secured data. What the VPN industry doesn't want you to know is that for the last 10 plus years, they've done nothing to secure your data. The reason I say that is because your data is already secured. We have in place end-to-end encryption. When you're dealing with your bank, for example, you do not need to get onto a VPN to secure that transaction. Your bank and your PC will negotiate a fully encrypted and secure connection. Nobody can see the contents of what you're doing. Nobody can modify or tamper in any way with that connection. I'll do a quick demo right now of how you can ensure that you're on a secure site when you're on the web. Here's an example of a simple web page. This is my own home page that I use on my own computer. I have my own domain called cantac.com. And even it, if you notice here, has an HTTPS address. Notice here this padlock icon. Currently, I'm using the Microsoft Edge browser. And whenever you go out to any website, I mean, it could be any website. You can go out to Amazon. Notice HTTPS and this padlock. I can go to Walmart, HTTPS, and the padlock. Any website will show you this icon. Any website worth its salt anyway. 99% of all websites are fully encrypted. If I click on this padlock, notice here I get connection is secure. If I expand that, I can actually click down here on certificate is valid and see some more details about the certificate in use. Now, how these certificates work and how it secures your data, your transaction, if you're dealing with Walmart or Amazon or any place else, is beyond the scope of this video. But believe me, if you see HTTPS with a padlock icon, you're secure. You're good. Nobody can tamper with your data. They can't inject data. They can't modify data. They can't monitor you. Your transaction, your activity is secure. Now, it's a little different with Firefox. If I pull up the Firefox browser, instead of seeing a padlock, you're going to see a shield in the current versions of Firefox. But it works the same way. You can click on that shield. You can see that your connection is secure. You can expand on that, get a little bit of certificate information. But other than the fact that there's a shield versus a padlock, it's the same thing. All modern web browsers do a very good job of supporting this secure system of HTTP plus TLS, which is transport level security. Now, if you do happen to go out to an insecure website, and you may have stumbled on this from time to time, you will get a big banner indicating connection is unsecure. And you'll have a chance to either proceed or back out of the request to go to that web page. I'm not going to read through this whole slide, but you can see that by and large, over 95% of all traffic is now encrypted. These are from Google, Mozilla, Cloudflare, and mobile data carriers. And again, in those rare cases when you encounter an insecure site or web page, you'll definitely see it. It'll pop up a whole screen of telling you this connection is unsecured. The consumer VPN industry has always wanted you to believe that this scenario was possible. The hacker in the coffee shop, just waiting to grab your credentials as soon as you did something. I always thought this was a bit of a laughable scenario. The return on investment must be horrible because the hacker must be waiting for someone to get on the internet and do some sort of transaction that he could sniff and glean some credentials from. It's just not a very good way to make a living. So not only was this an unlikely scenario, but in this day and age, it's impossible. With HTTPS, it doesn't matter whether that gal back there is doing any sort of banking or whether she's using a VPN or not. There's no way the hacker can even see what she's doing or intercept it. This is not only not plausible, it's absolutely impossible. This cannot and does not happen. Even without a VPN, should such a mythical hacker exist, he would be frustrated. He would have no place to go. He would see that the connection is secure because of end-to-end encryption. There is nothing he can do. So this whole scenario of the coffee shop hacker has always been a myth, in my opinion, and is definitely a myth today. VPN, essentially today, is adding a redundant level of encryption, and it only encrypts the hop to the VPN server. The encryption ends there. Your data, once it gets on the open internet, remains unchanged. Diagrams are nice, but I kind of like using real-world analogies sometimes, just in case some of you get intimidated by diagrams. Let me give you an example. Imagine this envelope is a data packet of yours. It could be a banking transaction. It could be anything, just a web request. It could be a piece of video that you're watching on a streaming service. In the old days of the internet, this was unencrypted. I mean, when I say the old days, I'm talking about 25, 26 years ago, around the turn of the century. So when the VPN provider would wrap that packet into an extra level of encryption, that did provide a little bit of value, at least between you and the VPN provider. That packet would then come to the VPN provider. We would then strip off the encryption added at the source at your PC, and then send the transaction on its way the rest of the way to the internet, with the only difference being the return address was altered to him. So when the packet came back, the VPN provider could then rewrap the envelope and then send it back to you, encrypted. So I always thought it was kind of laughable anyway, because the encryption was the extra encryption was only between you and the VPN provider. Nowadays, this envelope is totally secure. I may as well just seal it up here. I'm going to fold it in half just to represent that it's secure. All your transactions, everything you do on the web, is endpoint to endpoint encrypted. There is no need to put any more wrappers on top of it. The VPN provider will still do that. He'll still put it into a bigger wrapper, send it to himself. The VPN software in your PC will wrap it and send it to the provider. He'll strip off the encryption and send it on its way. But there really is no loss of security. This encryption that is in place now with HTTP and transport layer security is unbreakable. You're good to go. So there's no need for a VPN in terms of data security. Now, before I get into the privacy problems with VPNs, let's talk about what they can do for you, because there are a few good applications for consumer VPNs. Because a VPN provider can hide your original IP address from the websites you visit, they can provide a fairly effective means of bypassing geographic restrictions on services and data. Where VPN providers really add value is that many of them provide a large number of servers in many countries around the world. They can make it look like you've just come onto the internet from anywhere. This can be useful for accessing geo-locked content. However, keep in mind that streaming services access is never guaranteed, because the streaming providers, whether it be Netflix or Hulu or anyone, Disney Plus, they're constantly monitoring VPN IP ranges. And so even though you may be able to access certain streaming services one day from a certain VPN server, doesn't mean you'll be able to do that tomorrow. Now, another value that consumer VPNs can add is remote access to banking services. I'm speaking specifically of, say, an American worker who might be working in China. In order to access his home bank, say back in the States, he may have to get on a consumer VPN so he can look like he's coming from within the U.S. Some bank websites will not accept any sort of connection that they perceive as coming from outside of the United States. So that's a good example of where a consumer VPN can provide access that would normally be denied. Additionally, some people use VPNs to avoid ISP throttling of certain protocols and traffic. This happens a lot on cellular service plans. There's a lot of plans out there that will limit you to 480p, for example, for your video streaming, whereas if you have a VPN, you can sometimes get around that throttling by connecting to the streaming service via a VPN server. However, keep in mind, anytime you're doing any of these type of things, you're probably violating the terms of service for the service you are accessing. And so that could open you up to later denial of service should the streaming provider, or in this case, the ISP, discover that you're trying to circumvent their controls. Finally, there is, again, this is all due to the thin layer of anonymity that a VPN can provide due to IP address spoofing. However, be aware that this IP address spoofing can work against you. Let's talk about privacy now, because if you think being on a VPN provides you with any additional privacy, you're wrong. In fact, it does quite the opposite. Here's you on a VPN. It may be a bit of an exaggeration, but not by much. The problem is a consumer VPN does effectively hide the origin of your data and computer activity, at least at first glance, at a high level. And this is a problem because keep in mind, all internet activity nowadays is encrypted. But when you're coming off of a VPN server, your traffic is of unknown origin. You can think about it this way. I live in northern Alabama. If I just normally log into my bank, which is also in northern Alabama, at a high level, an intelligence agency can look at that and say, oh, there's some traffic from a residence to a bank in the same region. It doesn't draw any special attention. But if I hook up to a VPN, say I come out onto the internet in Los Angeles like I did earlier in this video, and then log into my bank in northern Alabama, now all of a sudden there's activity happening from a VPN server in California to a bank in northern Alabama. And there's no way to easily identify the origin of that data or who's causing those transactions. Is it another customer in northern Alabama? Or is it some nefarious activity from Iran, Russia, China? It could be anywhere on the planet. Such activity draws additional scrutiny from the NSA and other intelligence agencies, not to mention other internet providers. Legally, agencies like the NSA are restricted by the Fourth Amendment and statutes like there's a FISA Section 702, which forbids them from intentionally targeting U.S. citizens on U.S. soil without a warrant. However, they have some other primary directives, such as Executive Order 12333, that allow them to heavily vacuum up foreign intelligence. And essentially, what the NSA policy is this. If the location and identity of a communicator cannot be verified as American, it may be treated as foreign or of foreign interest until proven otherwise. In other words, the NSA can suck up your data and analyze it further, since it's coming off of a VPN server and they have no idea where it's coming from. This happens in other situations too. You may not be a target in particular for any scanning activity. If the NSA is in the process of vacuuming up data on particular servers and you just happen to be on that same server with your VPN, well, you'll get sucked up with the rest of the traffic. So just keep in mind that when you're on a VPN, you are basically throwing away a number of protections that you have as an American citizen. That is, I'm targeting, of course, those of you who are U.S. citizens watching this video. Each country, I'm sure, has different rules and regulations regarding the monitoring of internet activity. The real problem with VPN usage is that you are sharing an IP address that has been used by tens of thousands, perhaps hundreds of thousands of others. And VPN servers are used by bots, data scrapers, criminals of every kind love VPNs. Any sort of shadowy activity often goes over a VPN server. Therefore, the IP addresses used by VPN servers have a very poor reputation. And it's not just the NSA that's concerned. Google, Microsoft, Meta, which is Facebook, Cloudflare, and many others closely and aggressively scrutinize VPN traffic. And this creates a lot of problems. I had never used a consumer VPN prior to earlier this year. But shortly after I retired from my full-time position, I decided to make a YouTube video on speed testing. Being a novice video editor at the time, I thought I would save myself some work by running my speed test over a VPN in order to keep my IP address private, and off the video without having to do a lot of post-production editing. And it worked. The problem is, after I was done running those speed tests, I often stayed on the VPN for other activity. I might go out to Google, query ChatGPT, whatever. And over time, I started having some major issues. Every time I went out to Google, I was being presented with a CAPTCHA. I couldn't understand what was going on. Facebook, my account got locked out. ChatGPT or OpenAI was sending me some emails telling me, hey, we think your account's been hacked. We're seeing some activity from a remote location with your login. This and several other issues were starting to really frustrate me, and then I figured it out. I had been using the consumer VPN, the free servers. I'd been using both Firefox's free VPN, which I demonstrated earlier, as well as some servers from a VPN provider called Proton. In any case, it took a while for that problem to go away. Even after I turned off the VPN usage, I still had to live with Google CAPTCHAs and some other problems for a couple more weeks before my IP reputation sort of cleaned itself up. So just be aware that when you're using a VPN, you're using some very suspicious IP addresses, because these IP addresses are recycled over and over and over for thousands of different users, and all it takes is a few bad actors to mess things up for everyone else. On your screen right now are some of the things you could run into when you do use a VPN frequently. CAPTCHA hell, which is what I call it whenever you just get prompted over and over and over for CAPTCHAs, even for simple Google queries. Sometimes Google will just outright block the search. They won't complete the request. If you get some additional or forced login activity above and beyond the normal procedures with some of your accounts, that's a sign where they have begun to lose trust with your account. And one thing to watch out for is velocity checks. I would recommend you never do any sort of transactions over a VPN if you don't have to. If you're going to be making any purchases, if you're going to be doing any banking, if you don't have to use a VPN, don't. Because what happens is these banks, some of them are pretty sophisticated, and they'll be mapping where you're coming from. If they see you logging in from like northern Alabama, and then all of a sudden an hour later you're trying to log in from LA, that's going to start throwing some red flags. And that's the same thing with credit card transactions. They start seeing these unusual locations pop up for transaction activity, and that could quickly freeze your account until you get things straightened out. Now, there's a few of you out there that might be saying, hey, Chris, I run into those issues all the time, and I'm not using a VPN. And that's quite possible. Unfortunately, not all internet connections are created equal. I have an AT&T address that has not changed in over 5 years. But other providers don't necessarily work that way, especially the newer internet providers that haven't had a chance or can't afford to buy large quantities of IPv4 addresses, as these addresses are becoming scarce and rather expensive. If you're on Starlink or other satellite provider, if you're on T-Mobile or Verizon wireless home internet, where you're going to be under what's called CGNAT, Carrier Grade Network Address Translation. What CGNAT boils down to is you're recycling, or the ISP is recycling IPv4 addresses since it only has a limited pool for its total customer base. And this will potentially give you many of the same problems as using a VPN, because all it takes is one bad actor in the pool of IP addresses, and if you pick up that IP address later, you're going to inherit that lower reputation, that suspicion. Therefore, you may get some of these additional issues when you're using these types of internet services. If you must use a VPN, my number one advice is use it as little as possible. If you're using a consumer VPN for accessing geo-locked content, use it just for that. When you're going to stream that program you can't get otherwise, or if you need to go out to that particular website and do some business that you can't do otherwise, log into your VPN. Go out and get your VPN required business done, and then get off. Don't multitask while you're streaming. Don't do any other business. Don't go out to Google. Don't go out to ChatGPT. Don't go out to social media. I wouldn't do any of that on a VPN if you don't have to. The less you use your VPN, the better off you're going to be. There are other things you can do, like split tunneling, or maybe dedicate a browser for VPN-only usage. I've never had much of a discipline for being able to do some of these other steps, but if you can segment your VPN activity to a specific browser, that would be helpful. If you're overseas and you need to log into a bank, say in northern Alabama, try to pick a VPN server in the US that is as close to your bank as possible. That may reduce some issues. Overall, I don't think consumer VPNs are worth much, with the exception of geo-locked content. I can understand that need, and if that's the issue, by all means, subscribe and use a consumer VPN. But for myself, I've never paid a dime for a consumer VPN, and I'm not about to start now. I just don't have the need to use one on a regular basis. If you enjoyed this video, please give it a thumbs up so YouTube will better recommend this video to others. If you have any questions or comments regarding anything I covered in this video, please drop a note. I'll see what I can answer. And I'd be interested, for those of you who are using a consumer VPN, what you use it for. If there are any topics that I touched on in this video that you would like to see expanded upon, perhaps in a separate video, let me know. I'm always looking for recommendations for future videos. Thanks again for watching.